Good day, everyone. We are Group 9 from CE22S10, and we will be presenting the experiment number 6, Los Angeles Abrasion Test. Today's objective, an activity aimed to introduce the basic principles, significance, and procedures for the Los Angeles Abrasion Test for course aggregates. Next. Intended learning outcome. The student shall be able to first familiarize the Los Angeles machine. Second, determine the basic procedure in conducting the LA abrasion test. Third, determine the use and significance of the LA abrasion test.
For the discussion, the course aggregates are the course aggregate serves as a very important role in overall capacity of the concrete in terms of resistance in surface abrasion and wear. As with accordance to with ASTM C131 and C535 abrasion resistance, the Los Angeles abrasion test is being performed to test the resistance of the course aggregates in abrasion and wear. The test is widely used as an indicator for the coarse aggregate for its tendency to break and disintegrate during the handling of the fresh concrete. It involves milling the aggregate with specified number steel balls, depending to the grading of the test sample for a given time, sieving the material over 1.70 mm sieve or sieve number 12, and weighing the mass loss. So the resources that are going to be needed are 1 unit Los Angeles abrasion machine, 1 set of sieve, a weighing scale, 1 scoop, 2 pans, and 15 kg of coarse aggregates with size of 37.5 millimeter or smaller.
For the procedure, for preparation of materials, first is wash the 15 kg of coarse aggregates and remove all the adherent coatings and dust. Second is divide the 15 kg of coarse aggregate into 3 equal batches. Third is oven dry the 3 sample at 110 degrees positive negative 5 degrees Celsius or 230 degrees positive negative 9 Fahrenheit for 60 minutes. Then grade the 3 sample in accordance with ASTM C33. Next. For actual testing, first is place the 3 test sample at a time with the specified number of steel balls and charge the Los Angeles machine. Next is rotate the machine at a speed of 30 to 33 revolution per minute for 500 revolutions. After the prescribed number of revolution, discharge the materials from the machine and perform a preliminary separation of the sample on a sieve coarser than 1.17 mm or number 12. Next is wash the materials coarser than 1.17 mm number 12, oven dry at 110 degrees positive negative 5 degrees Celsius or 230 degrees positive negative Fahrenheit for 60 minutes and weigh the material. Next is sieve the finer portion on a 1.17 millimeter or number 12 in a manner conforming to ASTM C136 and weigh the material. For the last, record all the readings and calculate the necessary data.
Data and result. 6.1 Grading of test samples. Sieve size, square opening, containing 2 columns which is passing and retained on. For the first and second row, having the same estimated mass value, trial 2, which is 1,250 grams. And for the third and fourth row, with the same data in a mass, trial 1 with 2,500 grams, trial 2 with an estimated value of 1,250 grams. And for the 5 and 6th row, the same data is in the trial 3 estimated value of 2,500 grams. Summing it up, the trials, we can get a total of 5,000 grams for trial 1, 2, and 3. All these data are based on grading of test samples.
For this part of Los Angeles abrasion test, the grading used in trial 1 is B, in trial 2 is A, and in trial 3 is C. For the specific number of balls for trial 1 is 11, trial 2 is 12, trial 3 is 8. And for the dry weight of passing sieve number 12, the data is in the video reference, which is 1,291 grams. For trial 2, we assume to be 2013 grams, and trial C is 2,601 grams. The dry weight retained on sieve number 12 after washing in trial 1, which is in the video, is 3,753. But for the trial 2, we assume the dry weight is 3,669 grams and trial 3 is 2,459 grams. For calculating the abrasion loss, we divide the total weight over the weight passing sieve number 12 times 100%. For example, in trial 1, the given total weight is 500 grams, then we divide it to the dry weight passing sieve number 12 and multiply it to 100%. And that's how we get the 387.30%. We also did this procedure in trial 2 and trial 3. Lastly, we get the 24.9% in trial 1, 38.62% in trial 2, 50.82% in trial 3 using the formula for the maximum abrasion loss, which is the original mass minus mass retained, then divide the sum to the original mass, then multiply to 100%. 100. Next for the conclusion.
The group concluded that Los Angeles abrasion test measures the degradation of standard gradings of aggregates when subjected to abrasion and impact in a rotating steel drum with an abrasive charge of steel balls. To function satisfactorily in pavement, an aggregate must be sufficiently hard to withstand the abrasive effect of traffic over a long period of time. The hard aggregates will endure the crushing force, whereas the soft aggregates will be crushed to dust quickly. We recorded all the readings and calculated the necessary data. The result of maximum abrasion loss in first trial is 24.9%, second trial 38.62%, the third trial 50.82%. These are the percentage of the original sample mass passed through the sieve. The group executed the objectives effectively and learned to perform Los Angeles abrasion test. That's all. Thank you.